Binary number system part 2. In the previous session, I covered the basics of binary numbers. What are the binary numbers with emphasis on the base of 2 and the power of 2. In this session, I will further build upon that session. Now, in the previous session, we had derived the first 8 binary numbers like this. These were the first 8 binary numbers, and then I put them into a table, and this is how they appear. Okay, now let's using this table have a look at what are the possible values. Now what we are trying to derive is, if we are given n number of digits, what are the number of possible values? Okay, so let's look at these table and try to see if we can derive a pattern out of it and then convert that into a simple formula. Okay, so this is the table. Now if we start with one digit or one bit, right? So with one bit or one digit, how many possibles do we have? We have 0 and 1. Look at these, 0 and 1 are the only two possibilities. So we can say with one digit we are getting two numbers. Okay, now let's move on to two digits. With two digits we get 0, 0, 0, 1, 1, 0 and 1, 1. Now if you look at the table, the first two numbers are 0 and 1. Now these can also be looked at or written as 0, 0 and 0, 1. And therefore using two digits we get these four numbers. Okay, now similarly with three digits we can get, we can say we are getting eight values. How? If you look at the first four in the table, you'll see 0, 0, 0, 1, 1, 0 and 1, 1. If I add 0 in front of all of these four, this is how they will appear. And that is where we can say, using three digits, these are the possibilities of numbers we get. So they are starting from 0, 0, 0 all the way to 1, 1, 1. Okay, so these are the 8 values. So now if we look at the pattern, we can definitely derive a formula from it. So with one digit gives us what? If we raise that one digit, whatever 1 is, to the power of 2, we get 2 raised to the power 1 gives you 2 possible values. Now if we apply the similar thing with two digits, we can get 2 raised to the power 2 equal to 4 possible values. And likewise with three digits we get 2 raised to the power 3, 8 possible values. So we can generalize this and conclude that the formula is, if we are given n digits, binary digits or n bits, the total possible values would be 2 raised to the power n. Right? Apply this to any number of digits and that's what will give you the range, the total number of values available for that digit or bits. Okay. So this is what we conclude, right? With one digit we get this. And now if you have to apply the same thing to the further number, we want to go till 8 bits. So what we get? With 4 bits we get 2 raised to the power 4, 16 values. With 5 we get 2 raised to the power 32 values. With 6 we get 2 raised to the power 6, 64 values. With 7 we get 2 raised to the power 7, which is 128. And with 8 we get 2 raised to the power 8, which is 256 values. Okay, so this is how we conclude that if given n number of bits, apply the formula 2 raised to the power that n will give you the total number of values for that number of digits or bits. Okay, so this is our conclusion for this session till now, right? N digits, 2 raised to the power n gives you the total values. Let's move on and see and move our focus towards minimum and maximum values for those given number of digits. So this is what we had seen up till now. and we see if we have one digit, right? This is a simple case. We do it 2 raised to power 1, will give us 2, which is 0 and 1. Okay. Now, in this, the first number is 0, which has to be the minimum, and second number is 1, which has to be the maximum, right? 0 and 1 for one digit. So if I set it to 0, I get the minimum value 0, and if I set it to 1, I get the maximum value 1. Okay. Now moving on to two digits, right? So with 2 digits, the possible combinations would be these four: 0 0, 0 1, 1 0, and 1 1. Now, if I put both of my digits to 0, then you see we'll get the minimum value. And if I set both of my digits to or bits to 1, then I get the maximum value. So again, you see we are developing a pattern here, and the pattern says to get the minimum value, put all the bits to 0. To get the maximum value, put all the bits to 1. And let's look at the next one also, and then we can further hone on this. So with 3 digits or 3 bits, these are the possible values. How many values? 8 values. And now if I set all the 3 bits, in this case to 0, I get the minimum value, if you can see. And if I set all the 3 bits to 1s, I get the maximum value. Okay. So with this, we can definitely conclude that if n number of bits are given, and if we set all the bits to zeros, we get the minimum value. And if we set all of them to ones, we get the maximum value. And this is for binary numbers. Okay, so this is what we can conclude. And if we apply this outcome or this analysis to 8-bit numbers, and we say these are the 8 bits, rather than going and finding out all the 256 values, different values, all we can do is simply set all of them to zeros and conclude that this is the minimum value. And then for the opposite side, the maximum value, we can set all of them to ones like this and say that this is the maximum value. Okay. So now to summarize again, in this session, we have got 2 outcomes till now. One is given n number of digits, the total number of values would be 2 raised to power n. And the second one that we just concluded is to find the minimum value, set all the bits to 0. And to find the maximum value, set all the bits to 1s. Okay. Now, this was all binary. Okay. What are the possible values and what are the possible binary minimum and binary maximum? Now let's take this further and convert and see what are the equivalent minimum and maximum decimal values. So this is the chart. All I've done is extrapolated and put just the minimum and the maximum value columns here for each digit. And now in the previous session we had applied this 2 to power 0 base starting from the rightmost 2 to power 0, and as we move forward leftwards we had applied 2 to power 1, 2 to power 2 and so on. So let's use the same technique and fill in the binary numbers in here and convert them into equivalent decimal numbers. So starting with the first one, 0, if I have to apply this here, this comes here and I multiply it, and this is what the outcome is. 0 in binary converts into 0 in decimal. Okay. Moving on to the next number, which is binary 1. Okay. This is mindful. We are talking about 1-digit binary and seeing what is the equivalent what is the equivalent minimum decimal and what is the minimum 1-digit or what is the maximum decimal for it. Okay. So apply 1 here and then this is what we'll get, 1. Moving on to the 2-digit thing, right? Apply the 0 here and here and do the math, and this is what we'll get. Again 0 0, it doesn't matter, it will always result in decimal 0. Okay. Now moving on to the 1 1 binary 1 1, apply it like this, and this would result in a total number of 3. So with 2 digits, the minimum value in binary is 0 0 and maximum value is 1 1. Its equivalent in decimal, the minimum value is 0 and the maximum value is 3. Okay. And if we continue with 3 digits, so 0, I'm going to do it quick because this is no rocket science, it's simple. The outcome is always going to be 0 here. So this turns into 0, the minimum value is 0. And now if we move on to 1 1 1, okay, let's see what do we get here. Apply 1 here, 1 here and 1 here, and do the multiplication and then add them all together. So the equation becomes like this, and we get a result of 7. Okay. Now moving on to the 8-bit, jumping onto that, right? So zeros will be simple here. I'll fill up all of the coefficients to be zeros, multiply with 2, add them all together, the result is going to be 0. Okay, that's what we'll get. And now if I move on to all ones for 8 digits and apply them like this, fill the coefficients to all ones, they are all going to be like 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. This is what it is going to result in, and the end result would be 255. So that's what it is. So now from this, what can we conclude? We can easily conclude that for given n number of bits, let's see, we'll get a pattern here that the maximum value is what that's what we are trying to conclude. With n number of bits, we know the total values are 2 raised to power n. But look at this pattern, right? What are we seeing is if we subtract 1 from the range, then we get the maximum value. So with 1 digit, we get 2 raised to power 1, which is 2 values. And in this, the range is 0 to 1. Okay. And 1 is the maximum. So formula definitely applies. 2 raised to power 1, which gives us the total value, which is 2. Subtract 1 from it, that gives you the maximum value, which is 1. Okay. Which is 1. Okay. Now let's apply the same formula for 2 digits. So 2 raised to power 2 is the total number of values, right? Now the range for this is 0 to 3. 0 to 3. That's what we determined. What is the range? And now if we apply the same formula here, 2 raised to power 2 minus 1 gives us 4 minus 1, which is 3. 3 is the maximum value. Okay. Continuing on the same thing, same path, with 3 digits or 3 bits, we get 2 raised to power 3 values, which is 8. Now the range for this is, of course, 0 and 7, both inclusive. That's why 7 is by looking at it, we can see definitely 7 is the maximum. But to derive this using the formula, we have to use the formula 2 raised to power 3 minus 1, which is what? 2 raised to power 3 is 8, minus 1 gives us 7. So that's why the maximum value is 7. So we are concluding that the formula is accurate and correct and can be applied. Okay. Similarly, jumping on to 8 digits. So the total values would be 2 raised to power 8, which is 256. Now range for this is from 0 to 255, as we have derived in the previous slide. And just in a shorter way, if we apply the formula, 2 raised to power 8 minus 1 will give us the maximum value, which is 255. So the key takeaways for these sessions is 3 points. One is to identify the total number of values when you are given a certain number of digits. Second, for finding the minimum and maximum binary values, the method is set all the bits to 0. You will get the minimum value. set all the bits to ones, you will get the maximum value. And finally, if you want to find the maximum value, okay, mind be focus on the word maximum value in terms of decimal, all you have to do is apply the formula 2 raised to power n minus 1, where n is the number of bits or digits, and you will get the answer.